Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, can you quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. Quickly let me know in the chats if all of you can hear me, if I'm perfectly audible and visible to every one of you. I would want every one of you to let me know quickly in the chats with some fire emojis, yeah? With some fire emojis. Good evening, guys. Good evening. Good evening and welcome back. So, my dear students, you must be thinking, what is this particular series all about? What is this particular series all about? Since all of you must have heard the yesterday's live press conference from the Union Education Minister, right? Wherein it was not clearly told whether Re-NEET is going to happen or not, right? But he gave us a lot of hints wherein he categorically said that there are very less chances for the Re-NEET to happen, right? So we'll have to wait till 8th of July, till the final conclusion comes from the Supreme Court, right? So till then, we cannot say whether Re-NEET is going to happen or not. But at the same time, we need to be prepared for the worst, okay? What if, since there is very, very, very less probability, I would say less than 1% probability for the Re-NEET to happen, right? But what if it happens? So we need to prepare, we need to be prepared for that as well. Okay, so that is the point of creating this particular series. We have stopped all the other series on YouTube for now till 8th of July, right? Once everything is cleared. Okay, so we are going to revise almost entire syllabus of physics, chemistry, biology through conceptual questions, right? I will be showing you all the patterns of the questions, right? With the help of which you can revise all the chapters of your chemistry, and eventually Yavur sir is also going to help you in that for physics, and Ambika ma'am, HSP sir, they're also going to help you out in this as well. So every day we are going to have 2 sessions, one in morning and one in the evening, so that you remain in touch with the books, you remain prepared for the worst case scenario, right? I hope I'm perfectly clear to everyone. Yeah? I hope I'm perfectly clear to everyone. Right? So are you all ready for it? Guys, again, I'm repeating the same thing. We need to be prepared for the worst. We do not exactly know. There is no 100% surety whether Re-NEET is going to happen or not. First of all, this particular session is just to keep you in contact with the books. These particular sessions, this Revised India series, which we are starting on YouTube, it is basically going to be for the revision purpose, right? So that you keep on revising the things till the final conclusion comes from the Supreme Court on 8th of July. So till 8th of July, we have stopped all the other series which we started, like Infinity series we started for NEET 2025 aspirants. We have stopped that series for now till 8th of July. But this particular session is not for only the Re-NEET students, not for only those students who are waiting for 8th of July. This particular series will be for the NEET 2025 aspirants as well, right? Because eventually it's going to be a question practice, okay, which is absolutely going to be beneficial for all. Okay? So please and please do not ask me these questions whether Re-NEET is going to happen or not. I have no idea whether it's going to happen or not. But one thing I'm telling you with 100% surety, that the chances are very, very, very less. Minimal chances are there. Okay, so just to be prepared for the worst, we have started this particular series, which is Revised India, wherein your syllabus, physics, chemistry, as well as biology is going to get revised. Okay, through the questions basically. Right? I know you have lost the momentum. I know you have lost the rhythm, right? To get that rhythm back, what if the Re-NEET happens? You have to get the rhythm back. You have to get the momentum back. Just to create that thing again, we have started this particular series for all of you. Okay? So basically, again, I'm repeating the same thing. We want to be prepared for the worst case scenario as well. Okay? And the session is going to be short and precise only. All the sessions will be 1.5 hours like that. Nothing more than that. Okay? Perfect. So guys, which chapter do you want to start with? I know it's difficult for you to start, yeah, but then we have to. So which chapter do you want to start with? Which chapter do you want to start with? Which chapter do you want to start with? And from this particular session, you'll get the idea whether you still remember the things or not. Yeah? From this particular session, you will get the idea whether you still remember the things or not. So quickly let me know in the chats, which chapter do you want to start with? And the ones who have not smashed that like yet, do smash the like button and share this particular video with everyone so that everyone gets benefited out of these sessions as well. Perfect. I'm asking you, which chapter do you want to start with? Is it mole or redox? I know you have forgotten a lot of things, but these sessions are just for the recap purpose only. So no need to worry. All right, so let's get going. Let's get started with the mole concept, right? I have come up with almost like 40 questions from the mole concept, which is going to revise your entire mole concept for sure. And I would want you guys to be ready with your pen and paper again. Okay? I would want you guys to be ready with your pen and paper again. Yeah? Perfect, guys. So let's get going. Let's get started with the first question, which is on your screen. Look at the question carefully and give it a try and let me know the answer in the chats quickly. My dear students, the question says, what mass of sodium chloride? What mass of sodium chloride would be decomposed by 9.8 grams of sulfuric acid if 12 grams of sodium bisulfate and 3.65 grams of hydrogen chloride were produced in a reaction? So basically, my dear students, you are going to first of all write the reaction. And the reaction says that what mass of sodium chloride? So you are basically making sodium chloride. You are basically making sodium chloride to react with sulfuric acid. To react with sulfuric acid. And eventually, what are you getting? You are getting sodium bisulfate, which is basically your NaHSO4. With sodium bisulfate, what you guys are getting? You are getting hydrogen chloride, HCl as well. So this is the reaction that's given to us. As per the question, sodium chloride is reacting with H2SO4 and it is leading to the formation of sodium bisulfate. And with sodium bisulfate, you are getting HCl as well. Correct? Now, my dear students, look at the question carefully. The question says, what mass of sodium chloride? Let's assume the mass of sodium chloride as X grams. What mass of sodium chloride would be decomposed by 9.8 grams of sulfuric acid? By 9.8 grams of sulfuric acid. If 12 grams of sodium bisulfate, and 3.65 grams of hydrogen chloride is formed. So basically, we have to get the value of X. If you simply use the law of conservation of mass, conservation of mass, you can solve this question in just one statement, right? If you just use the law of conservation of mass, you can solve this question in one statement. And what is that statement? You just have to equate mass of reactants with the mass of products, right? Mass of reactants is supposed to be equal to the mass of products. And mass of reactants is just going to be X plus 9.8 is equal to mass of products is going to be 12 plus 3.65, right? And when you solve this particular equation, you'll be getting the value of X exactly as 5.85 grams. So you were supposed to get the value of X, and finally, you exactly got the value of X, which came out to be 5.85 grams, right? Now tell me in the chats, do you remember things or not? Tell me in the chats. It looks like you don't remember things, but actually things are there in the back of your mind. Yeah? Things are there in the back of the mind. So it just needs a quick recap, nothing else. I believe this particular question is absolutely clear to every one of you. I'm moving ahead to one more question. One simple and basic question this is. One simple and basic question. One atomic mass unit. My dear students, if you remember, I have taught you many a times 1 AMU, 1 atomic mass unit, which is also called as 1U, which is also called as 1D. How do you exactly define it? You define it as 1/12 of the mass of carbon-12 atom. You define it as 1/12 of the mass of carbon-12 atom. And my dear students, I hope you remember the value of 1 AMU in grams is mentioned as 1.66 into 10 raised power minus 24 grams, which as per the Avogadro's number can be written as 1 divided by Na grams. This is the statement which I believe all of you will be remembering. If not, then remember this particular equation from now onwards. Remember this particular statement from now onwards. Okay? So 1 AMU, which is also called as 1U, which is also called as 1D, it is defined as 1/12 of the mass of carbon-12 atom, which in grams is nothing but 1.66 into 10 raised power minus 24 grams. In terms of Avogadro's number, we mention it as 1 divided by Na grams. As simple as that. Now, accordingly, you can check your option. It is going to be 1.66 into 10 raised power minus 24 grams. Correct? Simple and basic question again this was. And I believe all of you would have easily solved this. Look at the next question. Look at the next question. The number of atoms in 0.1 moles of triatomic gas. So we are given with a triatomic gas. For example, the gas is A3. This is the triatomic gas. As per the question, how many moles of triatomic gas are we given with? We are given with 0.1 moles of triatomic gas. Okay? We are given with 0.1 moles of triatomic gas. Now, my dear students, if I ask you, how many molecules of A3 do we have? How many molecules of A3 do we have? We are given with moles, so we are just going to multiply the moles by the Avogadro's number. So I'll be getting the molecules. So these many molecules of A3 we have over here. But as per the question, am I supposed to calculate the molecules? No, I'm supposed to calculate the atoms, right? Now, you can just write a statement, simple statement. One molecule of A3 contains how many atoms? It contains 3 atoms. Now, my dear students, if one molecule of A3 contains 3 atoms, so I would say 0.1 Na molecules of A3 will be containing 3 multiplied by 0.1 Na, right? The value comes out to be 0.3 Na atoms. So these are the total number of atoms. These are the total number of atoms which are basically present in 0.1 moles of the triatomic gas. Am I clear with this? Am I clear with this? Quick. Am I clear with this? Yeah? So eventually you can put the value of Avogadro's number value, right? Which is 6.022 into 10 raised power 23, and you'll eventually get the answer of this question as well. So again, a simple and basic question this is. Look at this particular question. The question says, number of atoms of helium in 100 U of helium, right? So we have to get the atoms in 100 U of helium. We have to get the atoms in 100 U of helium. Now, my dear students, if I ask you, what is the atomic mass of helium? You'll say 4U. 4U is the atomic mass of helium. What does that mean? That means 4U is the mass of one atom of helium. 4U is the mass of one atom of helium. So if 4U is the mass of one atom of helium, so I would say 1U will be the mass of 1/4 atoms of helium. It will be the mass of 1/4 atoms of helium. But as per the question, am I given with 1U or 100U? I'm given with 100U. So 100U will be equal to 1/4 multiplied by 100. The value comes out to be 25 atoms of helium. Right? So basically, you got to know 100U is nothing. It is just 100U is nothing. It is just the mass of 25 atoms of helium. Nothing more than that. As simple as that. Moving on to one more question. Look at this particular question carefully, guys. It's again simple. The number of gram molecules. Gram molecules means moles. The number of gram molecules of oxygen. Since we are mentioning the term gram molecule, so I have to take oxygen as O2, not in terms of O, right? The number of gram molecules of oxygen in 6.02 into 10 raised power 24 carbon monoxide molecules. Okay. So my dear students, first of all, can you quickly let me know how many moles of carbon monoxide do we have? Can you quickly let me know how many moles of carbon monoxide do we have? 6.02 into 10 raised power 24 divided by Avogadro's number. Divided by Avogadro's number. So we have got basically 10 moles of carbon monoxide. As per the question, we have got 10 moles of carbon monoxide. Now, if I ask you, in 1 mole of carbon monoxide, how many moles of O are there? How many moles of O are there? I'll say 1 mole of carbon monoxide contains 1 mole of O. 1 mole of O, or you can say 0.5 moles of O2. 0.5 moles of O2, right? 0.5 moles of O2. So if 1 mole of carbon monoxide contains 0.5 moles of O2, therefore 10 moles of carbon monoxide contains 0.5 multiplied by 10, which comes out to be 5 moles of O2. Well, moles is something which you call as gram molecules here. So it contains 5 gram molecules of oxygen. It contains 5 gram molecules of oxygen, which is something I was supposed to calculate, right? So the answer is going to be absolutely option B. Perfect. Again, one simple and basic question this was, and I believe you have solved it properly. Look at this particular question. Guys, all these questions are absolutely going to revise the complete chapter for sure. Okay? Look at this particular question. 3.011 into 10 raised power 22 atoms of an element weighs 1.15 grams. The atomic mass of the element is, right? Let's see what the question says. As far as the question is concerned, you have got 3.011 into 10 raised power 22 atoms of an element, right? And these many atoms of the element have got the mass of 1.15 grams. Okay? As per the question, these many atoms of the element have got the mass of 1.15 grams. Therefore, I can say the mass of one atom of element, is going to be 1.15 divided by 3.011 into 10 raised power 22 grams. This is the mass of one atom of an element, right? If this is the mass of one atom of an element, therefore, the mass of 6.022 into 10 raised power 23 atoms. The mass of 6.022 into 10 raised power 23 atoms. That's going to be 1.15 divided by 3.011 into 10 raised power 22 multiplied by 6.022 into 10 raised power 23 grams. Correct? Now, it's just a matter of calculation. When you solve this, the value exactly comes out to be 23 grams. So what is this 23 grams exactly? This is the mass of 6.022 into 10 raised power 23 atoms of the element. So I would say this is the mass of 1 mole of the element. This is the mass of 1 mole of the element, right? And mass of 1 mole of the substance is something which you call as molar mass, right? So basically, I got the molar mass of the element as 23 grams. Now, if molar mass of the element is 23 grams, therefore, atomic mass of the element, you just have to change the units. Therefore, atomic mass of the element is nothing but, it's going to be 23 AMU, or you can say 23U, right? So, option A is the one which is going to be the correct answer of this particular question. I believe this is clear to everyone. Yeah? Right, people? Moving on to one more question. Similar type of question which I believe all of you can easily solve. Similar sort of question. The question is, let the molar mass of element A is 10 grams. You have got the element whose molar mass is A grams. You have got the element whose molar mass is A grams, right? The mass of 10 atoms of the element in AMU. Try to understand. If this is the molar mass of the element, so what will be the atomic mass of an element? What will be the atomic mass of an element? You just have to change the units. It's going to be AAMU. This is the atomic mass of the element. Atomic mass of the element means mass of one atom of an element. So basically, I got to know the mass of one atom of element. The mass of one atom of an element is AAMU. Therefore, the mass of 10 atoms of the element, as per the question, has to be 10A AMU. Correct? This is something which I was supposed to calculate as per the question. So it has to be 10A. Clear, guys? And at the same time, before doing the other questions, For all those students who have already made their mind to write the NEET examination in 2025, my dear students, on 24th of this month, we are starting the Phoenix 3.0 NEET English batch, right? So join that batch. Link is there in the description box of the video, right? The batch is starting on 24th of this month. That means after 2 days. And in that particular batch, we, the Unacademy NEET English team, we are going to train you completely in all the subjects. We are going to complete your whole syllabus in just 6 months, followed by 2 months of revision, right? On every Sunday, you'll have to write the tests, okay? Study material, DPPs, every single thing is provided, okay? So all those students who have already made their mind of taking a drop, all those students who have already made their mind to write the NEET examination in 2025, the link is there in the description, right? Okay, do get enrolled into that particular batch. The Phoenix 3.0, which is starting on 24th of this month. That means after 2 days, right? And there'll be 3 sessions per day, which will be live. And if by chance you were unable to join the live session, you have got the access to the recordings as well. Okay, let's move on. Let's move on. And at the end of the session, I'll give you the exact details of that particular batch. See guys, look at this particular question quickly. A mixture contains 5.4 grams of aluminium. So you have got aluminium, we have got magnesium, and you have got ethanol, which is C2H5OH. Right? These are the 3 substances which are present in the mixture. Now, as per the question, how many grams of aluminium are there? 5.4 grams of aluminium are there. 1.2 grams of magnesium are there. And 4.6 grams of ethyl alcohol. 4.6 grams, is that? Yeah. 4.6 grams of ethyl alcohol is there. What am I supposed to calculate? I'm supposed to calculate the ratio of their moles. I'm supposed to calculate the ratio of their moles. Now, my dear students, what exactly I'm going to do? I am given with the masses. I need to convert these masses into moles. How do I convert mass into moles? Given mass divided by molar mass, right? So, it's going to be 5.4 grams divided by molar mass of aluminum is 27. 1.2 grams. Molar mass of magnesium is 24. 4.6 grams. Molar mass of C2H5O6 is 46. Right? Perfect. So, now solve it. This value comes out to be 0. How much? 0.2. Right? It comes out to be 0.2. This value comes out to be 0.05. And this value comes out to be 0.1. Perfect. Now, which one is the least term over here? The least term is 0.05. I'm going to divide all these terms by 0.05. Dividing this by 0.05, dividing this as well as dividing this by 0.05. This value comes out to be 4, right? 4 is to, this value comes out to be 1, and this value comes out to be 2. So 4 is to 1 is to 2 is going to be the ratio of the moles of these substances which were given to us. Correct? Again, a simple and basic question, and I'm pretty much sure this is clear to everyone. Yeah? Moving on. Moving on, people. Look at this particular question. The question says, we have got the element iron, which has got 3 isotopes. Iron has got 3 isotopes. One is Fe54, one is Fe56, another one is Fe57. These are the 3 isotopes of iron which we are given with. Okay. Now, my dear students, as per the question, we are given with their percentage abundances. This is 5%, this is 90%, and this is 5% as per the question. Right? We are given with their percentage abundances. What am I supposed to calculate? I'm supposed to calculate the average atomic mass of iron. I believe all of you will be at least remembering the formula. Average atomic mass is calculated by the result M1A plus M2B plus M3C divided by A plus B plus C, which is always 100. Right? So people, what is M1, what is M2, and what is M3? See, this is the value of your M1 basically. This is the value of your M2, and this is the value of your M3. And as per the question, this is the value of A, this is the value of B, and this is the value of C. When you put all these terms in this particular equation, you get the average atomic mass of iron as 55.95 AMU. This is the average atomic mass of iron which I was supposed to calculate. And I believe all of you will be remembering this particular formula. Yeah? I believe all of you will be remembering this particular formula. Okay, the percentage of oxygen in CH2O. You're supposed to calculate the mass percentage of oxygen. You're supposed to calculate the mass percentage of oxygen in what? In CH2O. How do you get the mass percentage of oxygen in CH2O? First of all, what is the molar mass of oxygen? That is 16 grams multiplied by. In 1 mole compound, how many moles of oxygen are there? In 1 mole compound, there is 1 mole O divided by. What is the molar mass of entire compound? This is 16. 16 plus 2 is how much? 18, right? 18 plus 12. 18 plus 12 is 30. And just multiplied this with 100, you'll be getting the mass percentage of oxygen over here. Correct? Simple. Absolutely, this one simple question. And after solving, you get the value exactly as 53.3%. Now, look at this particular question, guys. Look at this particular question quickly. The question is, what volume of oxygen measured at 0 degree and 1 atm is needed to burn completely 1 liter of propane? Right? So as per the question, what are we burning? We are doing the combustion of propane, right? We are doing the combustion of propane. And combustion of your organic compound, right? It leads to the formation of your carbon dioxide here, and it leads to the formation of water as well. Now, first of all, if you look carefully, is the reaction balanced or not? The reaction is not at all balanced, so I'll try to balance the reaction. This is 3, so make it 3. This is 8, so make it 4, and this will be 5 times. The reaction is now balanced. After balancing this particular reaction, if you look carefully, stoichiometry coefficient here is 1, here it's 5. Can I say, as per stoichiometry, 1 liter propane, it requires 5 liters of O2 for complete combustion? Yes, 1 liter of propane requires, as per stoichiometry, 1 liter of propane requires 5 liters of oxygen for its complete combustion. That's something which I was supposed to check. For the complete combustion of 1 liter of propane, how many liters of oxygen do we get? We need 5 liters of oxygen. Done and dusted again. Alright, look at one more question. You are given with a reaction which is given in the balanced format. The reaction is given in the balanced format. Let me note down the reaction again. The reaction is zinc solid plus 2 times HCl. It gives ZnCl2, and with that you get hydrogen gas as well. Now, my dear students, as per the question, initially at time t is equal to 0, you have got 0.3 moles of zinc, you have got 0.52 moles of HCl. So initially this will be 0, this will be 0. What am I supposed to calculate? How many moles of hydrogen gas are produced, right? So which concept we are going to use here? We'll be using the concept of limiting reagent. First of all, in the limiting reagent concept, I hope you remember we are supposed to balance the reaction first. And the reaction is already given in the balanced format. Reaction is given in the balanced format. Now, after balancing the reaction, I'm supposed to identify which one is the limiting reagent. How do you exactly identify? Given moles divided by stoichiometric coefficient. The one that gets the lesser value, that's always the limiting reagent. So 0.3 divided by 1, that is 0.3. 0.52 divided by 2, that is 0.26. So HCl is getting the lesser value here. So HCl is the limiting reagent. If HCl is the limiting reagent, it would have got completely consumed, right? And entire product formation is decided by HCl over here, right, people? So look at the stoichiometric coefficient, that's 2 here. Stoichiometric coefficient is 1 here. If you use the stoichiometry, as per stoichiometry is concerned, 2 moles of HCl should form 1 mole of H2. Therefore, 1 mole of HCl should form 1 by 2 moles of H2. Therefore, 0.52 moles of HCl should form 1 by 2 multiplied by 0.52, which comes out to be 0.26 moles of hydrogen gas. So you got to know 0.26 moles of hydrogen gas is being produced at the end of the reaction. Correct? Again, one simple and basic question which I believe you can easily solve. Okay? Look at this one more easy question, guys. Look at this particular one. Calculate the minimum mass of Cl2. Calculate the minimum mass of Cl2 in grams. Calculate the minimum mass of Cl2 in grams required to produce 37.25 grams of KCl. So we are supposed to produce 37.25 grams of KCl through this particular reaction. So first thing, if I ask you, how many moles of KCl we are supposed to produce? I'll say these many grams divided by mass of KCl divided by molar mass of KCl, right? So as per the question, we are supposed to produce 0.5 moles of KCl. As per the question, we are supposed to produce 0.5 moles of KCl. We are supposed to produce 0.5 moles of KCl. Now, in order to produce 0.5 moles of KCl, what is the mass of Cl2 that is required? So I'll simply use the stoichiometry. I can say 1 mole of KCl is produced from 1 mole of Cl2. If 1 mole KCl is produced from 1 mole Cl2, therefore 0.5 moles of KCl will be produced from 0.5 moles of Cl2. As simple as that. So I got to know the moles of Cl2 which are required. I got to know the moles of Cl2 which are required to produce what? To produce 0.5 moles of KCl. But as per the question, was I supposed to calculate moles of Cl2? No. I was supposed to calculate mass of Cl2. So mass of Cl2 is going to be equal moles of Cl2 multiplied by molar mass of Cl2, which is 71 grams. So finally, the value comes out to be 35.5 grams. So I would say 35.5 grams of Cl2 are required to produce 37.25 grams of KCl as far as the question was concerned. I hope I'm clear with this. Let me know once in the chats. Yeah? Clear? Perfect. Let me move on to one more question then. Look at the question, guys. Again, one simple basic question. You just need to use your brain a bit in this particular question. 0.44 grams of a colorless oxide of nitrogen occupies 2 to 4 ml at STP. The molecular formula is, again, one simple and basic question. I must say this is, my dear students, as per the question, 224 ml of the gas, 224 ml of the gas, as per the question, it has got the mass of 0.44 grams. Correct? It has got the mass of 0.44 grams. Therefore, 1 ml of the gas has got the mass of 0.44 divided by 2 to 4 grams. So I can say 22400 ml of the gas at STP will have the mass of how much? 0.44 divided by 224 multiplied by 22400 grams. When you solve this, the value comes out to be exactly how much? 44 grams. So this is the mass of 22400 ml of the gas at STP. So I would say this is the mass of 1 mole of the gas at STP. This is the mass of 1 mole of the gas. And you must be knowing the mass of 1 mole of gas is something which you call as molar mass. So I got to know molar mass of the gas is 44 grams. Now look at all the options and check which of the following gas has got the molar mass of 44. Now it's hit and trial. So if you look at the option C, this is 16 plus 28. 16 plus 28 comes out to be 44. So its molar mass is 44. So the gas has to be N2O. Correct? The gas has to be N2O. Perfect, people. Moving on to one more question. Look at this particular question. Again, one simple and basic question this is. And I'm pretty much sure you can easily solve this. The question is 14.2 grams of Na2SO4 is present in 10 raised power 2 kg of water. Its concentration in ppm, right? So we are basically supposed to calculate parts per million of solute. Parts per million of solute, as per the formula, it's going to be mass of solute in grams divided by mass of solution in grams multiplied by 10 raised power 6. This is the formula which you'll be using, right? Now, what is the mass of solute? As per the question, the mass of solute is 14.2 grams. What is the mass of solution? Mass of solution will be mass of solute plus mass of solvent. Mass of solute is 14.2 grams. Mass of solvent is 100 kg means 100 kg means these many grams, 10,000 grams. Okay? Correct? Right, people? So I think 5 zeros, right? 1, 2, 3, 4, 5. So these many grams. So this is the mass of solute. This is the mass of solvent, right? So if you want to calculate mass of solution, so this plus this approximately can be written as this only, because 14.2 is definitely negligible as compared to 1 lakh. Okay, so I'll consider the mass of solution as 10 raised per 5 grams only. This grams only, multiplied by 10 raised per 6. The value exactly comes out to be 142. So parts per million of solute over here is coming out to be 142 ppm. Okay. Again, this is one simple and basic question, which I believe all of you can easily solve. Look at this question, guys. Look at this question. If 3.01 into 10 raised per 20 molecules are removed from 98 milligrams of H2SO4, then calculate the number of moles of H2SO4 left. So we are supposed to calculate the number of moles of H2SO4 that are left. It will be equal to number of moles of H2SO4, taken minus number of moles of H2SO4 that are removed. Correct? That are removed. So how many moles of H2SO4 were taken? 98 milligrams. 98 milligrams means 98 into 10 raised per minus 3 grams. If I divide it with the molar mass of H2SO4, so these are the moles of H2SO4 taken. Given mass divided by molar mass. These are the moles of H2SO4 taken. Minus. How many moles of H2SO4 are removed? These many molecules are removed. 3.01 into 10 raised per 20 molecules are removed. So divide it with the Avogadro's number, right? So these are the moles of H2SO4 removed. These are the moles of H2SO4 taken minus these are the moles of H2SO4 removed. Solve it and get the moles of H2SO4 left at the end when you remove these many molecules. I hope this again clear to all of you. And when you solve this, you'll be getting the value exactly as 0.5. Look at this particular question, guys. Look at this particular question. Again, a simple basic question this is. The simplest formula means empirical formula you have to calculate. So you have got the compound that contains two elements, X and Y. Their mass percentage, I believe, is given as per the question. If this is 50%, this also has to be 50%. Their atomic weights are given to us, 10 and 20. So my first step is to calculate the atomic ratio. How? So 50 divided by atomic mass of X is given to me as how much? 10. Similarly, this 50 divided by atomic mass of Y is given to me as 20. When you solve this, the value comes out to be 5. This value comes out to be 2.5. Right? Okay, now which one is the least among the two? 5 or 2.5? 2.5 is least. So if I get the least atomic ratio, that's going to be 5 divided by 2.5. Similarly, 2.5 divided by 2.5. I hope you remember this. So this value is equal to 2, this value is 1. So simplest ratio came out to be 2:1. So empirical formula has to be X2Y1. This is the empirical formula of the compound. X2Y1 is the empirical formula which you were supposed to calculate. I hope this is all clear to every one of you. Right? Look at this particular question. Again, one simple and basic question this is. Right? Use your brain a bit and solve this. You have got two gases O2 and N2. Their mass ratio is given. So mass of O2 divided by mass of N2, this is given to me as 1 by 4. What am I supposed to calculate? The ratio of their molecules. You know, if you calculate the ratio of moles, that is something which will give you ratio of molecules. Ratio of moles and ratio of molecules is eventually going to be the same. So I'll just try to calculate ratio of moles. That has to be the ratio of molecules as well. So let's try to calculate ratio of moles. Number of moles of O2 here will be equal to mass of O2 divided by molar mass of O2. Number of moles of N2 will be equal to mass of N2 divided by molar mass of N2. Now, as per the question, this particular term is given. It is given to us as 1 by 4. Similarly, what is the molar mass of N2? 28. What is the molar mass of O2? 32. The value comes out to be 7:32. So this is basically the ratio of the moles of O2 and N2 which I was supposed to calculate. Okay, so 7:32 is going to be the correct answer of this particular question. Right, people? Look at one more question. Guys. These many molecules of urea are present in 100 ml of its solution. The concentration of urea is, concentration means molarity, right? Molarity will be equal to number of moles of urea divided by volume of solution in liters, right? So how many moles of urea do we have? So we have got these many molecules, right? So what does that mean? How many moles of urea we have? So this divided by Avogadro's number. This divided by Avogadro's number comes out to be 10 raised power minus 3. So these many moles of urea we have. Volume of solution in liters. Volume of solution is given to me in ml. So I'll be dividing this term with 1000, right? I'll be getting 0.1, which means 10 raised power minus 1. So 10 raised power minus 1 liters. So overall, the value comes out to be 10 raised power minus 2 molar, right? So 10 raised power minus 2 means 0.01 molar solution we have. Again, a simple and basic question this was. And I'm pretty much sure you easily solved this. All right, look at one more question. This is the asked question, by the way. If Na is the Avogadro's number, then the number of valence electrons in 4.2 grams of nitride ion. So first of all, in order to calculate the valence electrons, can you let me know how many moles of nitride do we have? Given mass of nitride in grams divided by molar mass of this N will be how much? 14 grams only. The value comes out to be 0.3. So these many moles of N tri-negative we have. So if I ask you, how many ions of N tri-negative do we have? How many ions of N tri-negative do we have? I'll say 0.3 Na. So these many ions of N tri-negative we have. Okay. Now tell me, in one N tri-negative ion, how many valence electrons are there? See, in one N tri-negative, there are total 10 electrons, out of which 2 will go in the first shell, 8 will go into the second shell. And those 8 electrons, I'll be calling as valence electrons. So it contains 8 valence electrons. If one N tri-negative contains 8 valence electrons, therefore 0.3 Na N tri-negative ions will be containing 8 multiplied by 0.3, which is 2.4 Na valence electrons, right? So these many valence electrons are basically present in 4.2 grams of N tri-negative, which I was supposed to calculate. I hope all the things are getting revised properly. And I hope you are continuously remembering all the things now. Now let's go into the redox. Okay, let's go into the redox. Tell me the answer of this question. The oxidation state of chlorine in CaOCl2, which is what you call as bleaching powder. CaOCl2. Quickly. CaOCl2. CaOCl2, bleaching powder. If you want to make its a rough structure, this is O, this is Cl, and let it be calcium, let it be Cl. This is its rough structure, right? Perfect. CaOCl, this is Cl. Now we have to talk about this chlorine and this chlorine. Now look carefully. This chlorine is attached with oxygen. And among oxygen and chlorine, which one is more electronegative? Oxygen, right? So due to this particular bond, oxygen will have -1, chlorine will have +1. Now this chlorine, it is attached directly with calcium. So it will have +1. Sorry, it will have -1. So one chlorine is in +1 oxidation state and one is in -1. So option 3 is the one which is correct among all. Right? Similarly, moving ahead. Look at this one. The oxidation number of the underlined atom in the following species is given. Identify the incorrect option. Identify the incorrect option. My dear students, which one do you see is the incorrect option? As far as I see the options, Cu2O. Cu2O, right? This one has to be the charge here. This too has to be the charge here. So oxidation state of copper has to be +1 here, right? But it's mentioned as -1. So this is incorrect. This is incorrect, right? Just crisscross the things and we are sorted. We are done. Oxidation state of chromium in CrO6. I believe you all will be remembering the structure of CrO6. This is chromium, right? This is oxygen, oxygen single bond. Similarly, oxygen, oxygen single bond. Similarly, oxygen, oxygen and a single bond, right? This is the structure of your CrO6, right? So chromium is basically attached with 6 oxygen atoms with the help of a single bond, with the help of which chromium will have the oxidation state of +6, right? It will have the oxidation state of +6, right? Because if you talk about this particular bond, due to this bond, chromium will have +1. Due to this bond, chromium +1, +1, +1, +1, +1. Eventually, it makes it +6. Okay, eventually it makes it +6. Look at this question. What is the change in the oxidation number of carbon in the following reaction? Change in the oxidation state of carbon in the following reaction. So if you look at this particular carbon, which is attached with hydrogen. So carbon here is in -4 oxidation state. Here carbon is in +4 oxidation state, right? So -4 to +4, that is the change in oxidation state. Again, it is the asked question only. You should be knowing it. You should be knowing it. You should be knowing it. All right. If you talk about PO4 trinegative, PO4 trinegative, what will be the oxidation state of phosphorus? How do you do it? How do you calculate it? Let the oxidation state of phosphorus be X. Oxygen will show -2 oxygen state. There are 4 oxygen atoms. Net charge is -3. So the value of X comes out be +5. Right? Similarly, sulfur in sulfate. Let it be X. Oxygen will show -2. There are 4 oxygen atoms. Net charge is -2. The value of X comes out be +6. Chromium in Cr2O7 dinegative. When you solve it, it will come out to be +6, right? So +5 +6 +6. +5 +6 +6. So option 4 has to be the correct answer of this question as well. Substances that are oxidized and reduced. Which of the following substances are oxidized and reduced in the following reaction? Look at the reaction, guys. What is the oxidation state of nitrogen here? It will be -2. Right? When you calculate it, 2x plus 4 is equal to 0. So -2. Nitrogen here is 0. So -2 to 0. Increase in the oxidation state. So this species is undergoing oxidation. So it is oxidized. If this is oxidized, that means H2O2 automatically will be getting reduced. So what I was supposed to check? Substances that are oxidized and reduced. So N2H4 and H2O2. These are the substances which are oxidized and reduced, right? Respectively, in the reaction. Look at this particular question. NH4NO3. My dear students, if you remember, it is a special case NH4NO3 which exists in the form of NH4 positive dot NO3 negative, right? You need to calculate the oxidation states of these 2 nitrogen atoms. So what I'll be doing, I'll be considering this one as the separate entity. I'll be considering this one as a separate entity. Then I'll be calculating their oxidation states. Let the oxidation state of nitrogen here is X. Hydrogen will show +1. There are 4 hydrogen atoms. Net charge here is +1. So the value of X comes out to be how much? -3. So -3 here. Similarly, you can calculate here. It's going to be how much? It's going to be +5. So -3 + 5 is the correct answer. -3 + 5 is going to be the correct answer here. Guys, again, you are asking me the same questions, right? Whether Re-NEET is going to happen or not. We do not know. Till 8th of July, right? We cannot say anything. Tell me the answer of this particular question. It's again a simpler one. Carose acid, Marshall's acid. Carose acid is basically your H2SO5. And your Marshall's acid is nothing but H2S2O8. One is Carose acid, one is Marshall's acid. Now, if you look at the structure of your Carose acid, and your Marshall's acid, okay, since you have drawn the structure of Carose acid and Marshall's acid, so you can directly say oxidation state of sulfur here as +2 +2 +1 +1, so +6, right? Similarly, in case of Marshall's acid, this is at +6, this is also at +6, so average is also +6. So it's going to be +6, +6. That's the correct answer of the question, right? It has to be option A. It has to be option A. All right, the oxidation state of phosphorus in BaH2PO2 whole twice. So you are given with BaH2PO2 whole twice. You need to calculate the oxidation state of phosphorus. Now look carefully. Barium is group second element, right? It's group second. And group second elements, they show the oxidation state of +2. You know it. Plus, hydrogen is going to show +1 oxidation state. And we have got 4 hydrogen atoms. Let the oxidation state of phosphorus be X, which makes it 2X. Oxidation state of oxygen is going to be -2. There are 4 oxygen atoms. Net charge is 0. When you solve this, I believe X value will come out to be +1, right? Which I was supposed to calculate, right? Perfect. All right, look at this particular question also. Calculate the N factor of this ferrous oxalate. Calculate the N factor of ferrous oxalate. First of all, my dear students, try to understand. This iron is in +2 oxidation state. This carbon is in +3 oxidation state. This iron +3 and this carbon +4. So if you look carefully, what is happening to the oxidation states? Oxidation state of iron is increasing. Oxidation state of iron is increasing. Oxidation state of carbon is also increasing, right? So I would say this ferrous oxalate, it is that species in which oxidation state of more than one element is increasing. How do you calculate its N factor? Whenever you see such kind of the species in which oxidation state of more than one element increases, its n factor is basically calculated as n1 plus n2. Now, what is n1? What is n2? Let's calculate that. What is n1? What is n2? n1 plus 2 to plus 3 plus 2 to plus 3. What is the change in oxidation state? 1, right? So n1 value is 1. n2 value plus 3 to plus 4 plus 3 to plus 4. What is the change? Change is 1. But that 1 is the change for 1 atom of carbon, but I have 2, right? So n2 value is 2. So 2 plus 1 makes it exactly as 3. So n factor of this ferrous oxalate is nothing but 3. Okay? This rule, I believe you remember that, right? If not, then, I mean, it would have got revised, I believe. Look at this one. Look at this one. We need to calculate the n factor of Cu2s, right? N factor of Cu2s. So, copper is in plus 1, sulfur is in minus 2, and here copper is in plus 2 and sulfur is in plus 4. So, check it out now. Copper plus 1 to plus 2, increase, right? Minus 2 to plus 4, increase, right? So, again, this is a species in which oxidation state of more than one element is increasing simultaneously. So, its n factor has to be n1 plus n2. So, how do I get n1 and how do I get n2 now? What is n1? Plus 1 to plus 2. Plus 1 to plus 2. Change is 1. 1 is the change for one atom, but I have 2. So, n1 value is 2. Minus 2 to plus 4. Change is 6. 6 is the change for one atom and I have 1 only. Right? So, 6 plus 2 makes it 8. Perfect. 6 plus 2 makes it 8. Now, look at one more question. Look at one more question, guys. You've got a reaction in which Br2 is getting converted into BrO3 negative. And with this, you have got Br negative as well. Now, as per the question, what are we supposed to calculate? Calculate the n factor of Br2. All right. See, oxidation state of bromine here is 0. Here it's plus 5. Here it's minus 1. So, 0 to plus 5 means increase in the oxidation state. 0 to minus 1 means decrease in the oxidation state. And you know, whenever the oxidation state of same element simultaneously increases as well as decreases, we say that particular species undergoes disproportionation. And how do we calculate the n factor of that substance which undergoes disproportionation? There's a simple trick. I believe you remember that. N1, N2 divided by N1 plus N2. Now, get the value of N1 and N2. 0 to plus 5. Change is 5. 5 is the change for one atom. I have 2. So, 5 2s are 10. So, N1 value is 10. Similarly, 0 to minus 1. Change is 1. 1 is the change for one atom. I have 2. So, N2 value is 2. Right? So, this is going to be 10 multiplied by 2 divided by 10 plus 2. The value comes out to be 20 divided by 12. This is going to be 4, 5, 4, 3. So, 5 by 3 is basically going to be the n factor of Br2 in this particular reaction. Correct, guys? Simple. And I believe you'll be remembering all this. I believe you'll be remembering all this. Okay. Balancing. You've got a reaction in which MnO4 negative, you're making it to react with oxalate ion, right? And it is giving us Mn di positive. With that, you are getting carbon dioxide. How do you balance the reaction in acidic medium? You should remember it. You should remember it. See, the n factor of MnO4 negative here is going to be 5 because its oxidation state is changing from plus 7 to plus 2. N factor of oxalate. Carbon is changing its oxidation state from plus 3 to plus 4. Change is 1. 1 is the change for one atom. I have 2. So, its n factors 2. Now, crisscross these n factors. Make this 2 as coefficient here. Make this 5 as coefficient here. Okay. So, this 2, make it 2 here. This is 5 to 10, make it 10 here. Now, balance all the oxygen atoms with the help of water molecules. So, how many oxygen do we have on left side? 5, 4, 20. 20 plus 4 to 8. 28. And this side we have got 20. Which side is oxygen deficient? Left side is oxygen deficient. Right? 8 oxygen deficiency is there. So, add 8 water molecules. Okay. Now, A2s are 16. So, add 16 H positives on this side. The reaction is balanced. No need to check it. The reaction is balanced. Yeah? Yes, Afnan. Nothing to do. Right? We have to wait for till 8th of July. Yeah. We have to wait till 8th of July. Nothing to do. So, we have to do the revision only so that you remain in touch. What if Re-NEET happens? Right? Possibility is there. Perfect. Moving on. So, moving on to this question. What do you think? What do you think? As per this particular question, potassium permanganate is titrated against ferrous ammonium sulfate in acidic medium. In acidic medium, your KMnO4, you need to remember it. KMnO4 in acidic medium gets converted into what? Gets converted into Mn di positive. Oxidation state here is +7, here it is +2. So change is 5. So its N factor of KMnO4 here is 5. If N factor of KMnO4 is 5, equivalent mass of KMnO4 is going to be molar mass of KMnO4 divided by N factor, right? So molar mass divided by 5 is the answer. Correct? Right, people? Did I solve this question incorrectly? Just a second. 4 2s are 8, 5 4s are 20. Correct? So 20 plus 8, 28 water mole, 28 oxygen atoms on this side. Okay, sorry. There's a mistake here. Just. 5 4 28. 28 oxygen atoms on this side. Only 20 oxygen atoms on this side. So this side is oxygen deficient. Okay. So add 8 water molecules on this side and 16 H positives on this side. Now it's a balanced reaction. Okay. So I just interchanged. Yeah. Perfect. Moving on. This question is done, right? What do you think is the equivalent mass of As2S3 in this reaction? As2S3. Check it out carefully. As2S3. This is not As2S4, this is As2S3. Okay? So this arsenic is in +3 oxygen state, sulfur is in -2. Just crisscross things. Arsenic here is in +5 and sulfur is in +6. So check it out now. +3 to +5 increase. -2 to +6 increase. So how do we calculate its N factor? I told you a few minutes back only. N factor is nothing but N1 plus N2. So get N1, get N2. Get N1 and N2. N1. +3 to +5 changes to 2 is a change for 1 atom. I have 2. 2 2s are 4. Similarly, -2 to +6, 8. Change is the 8. 8 is the change for 1 atom. 8 3s are 24. So 24 plus 4 makes it 28. So N factor is 28. So equivalent mass is going to be molar mass divided by N factor. Correct? Correct, people? All right. Equivalent mass of H3PO4 in this reaction. So let me write the reaction. Reaction is H3PO4 plus calcium hydroxide. It gives CaHPO4 plus 2 times water. So how many water molecules are being produced? 2 water molecules are being produced. So in order to produce 2 water molecules, I'll say this species would have given 2 H positives, this species would have given 2 OH negatives, and they would have reacted and formed 2 water molecules. So look at this particular acid. This acid is donating 2 H positives. So I would say the basicity of the acid is 2. Therefore, its N factor has to be 2. Whatever is the basicity of the acid, that's what you call as N factor of the acid. And once you get the N factor of acid, you got its equivalent mass. Equivalent mass will be molar mass 98 divided by 2. 98 divided by 2 is nothing but 49. Correct? Correct, people? So I believe, right? At least you got the touch of mole and redox in this particular session. I told you this session is going to be short and precise only, right? I just took the session for 1 hour. I know it's going to be really difficult for you to sit right now and study all this again, which is very difficult. I can understand that. But just to get you on the track, we'll keep on having these revision sessions till 8th of July, right? Because we do not know what is going to be the next. We do not know what is going to happen. We do not know what's going to happen. Tomorrow in the morning, I'm going to post a session that is going to be a complete GOC one shot. Watch that particular session as well so that you basically revise things. That's what I want. That's what I want. And all those students who are basically the NEET 2025 aspirants, guys, you can see the link which is pinned in the chats, and the same link is there in the description box of the video as well, right? So join the Phoenix 3.0 batch. We are starting the batch as soon as possible, right? And it's right now at the minimal cost, 5499, right? And let me give you the batch details of Phoenix 3.0 so that you'll understand what this Phoenix 3.0 batch is all about. So this particular batch is, first of all, for all the NEET 2025 aspirants. Whether you are the dropper, whether you are writing for the first time, second time, does not matter. Okay? All the NEET 2025 aspirants, your complete syllabus will be done and dusted in 6 months. 6 months for the complete syllabus completion of physics, chemistry, biology. Every chapter will be started from the basics only. So whether you have started that, whether you have studied the chapter before or not, does not matter. We are starting all the chapters from the basics, from the scratch. We are completing all the theory and all the problem patterns in the class itself. And right after the class, we give you the DPPs and the study material, right? Which is something which we provide. You do not have to solve any other book apart from the study material and the DPP which we provide you. No book you have to solve. Okay, no book you have to solve. And there will be tests on every Sundays. Tests on all the Sundays, right? So in this particular batch, we'll make you write 50 plus tests basically. We will exactly make you write 50 plus tests. Perfect. Right? And there will be one-on-one mentorship sessions with me. Like I took a session yesterday, the mentorship session, right? Over the Zoom meeting with a lot of students. I spoke to them exactly. I got to know. I checked their test score on Sunday, right? And eventually I had a meeting with them yesterday so that I could get to know where they're lagging and how they can improvise. So all these things, they keep on happening, right? In this particular batch. The batch is starting on 24th of June, right? It might be delayed for 2-3 days, right? It might be delayed. I do not know exactly, but it might be delayed. So right now the tentative date for the batch to start is 24th, and this batch right now is at 5499 its prices, and after 23rd of June you will get the same batch exactly as at 7999. So all those students who have basically made their mind of taking a drop, you guys can join into the batch, right? And after that, just you can trust your Unacademy NEET English team. We know exactly how to take you from 0 to 700 plus for sure, right? So just follow whatever we tell you to follow in this batch. Nothing else. You do not have to use your brain. Whatever things are required to crack this examination with a really amazing score, all those things we have incorporated here in this Phoenix 3.0 batch, right? Okay. And at the same time, how do we get enrolled here in this particular batch? So first of all, guys, your Unacademy NEET English team, like I'll be taking care of your chemistry, physical I'll be doing, inorganic I'll be doing, and some of chapters of organic also I'll be doing, right? Similarly, complete biology, your zoology as well as botany will be taken care by Ambika ma'am, and your complete physics will be taken care by Yavar sir. So we are the 4 educators who are going to be with you throughout this year, right? Throughout this year. Perfect. So all those students who still have not joined in, I would highly recommend you guys as an elder brother to join the batch, and let's kickstart the preparation from 24th itself, right? The Phoenix 3.0. How do we join this particular batch? Hey guys, this is the video which you guys are watching. There's a link in the description. That is 1 year NEET UG subscription. Click on this link. Once you click on this link, right, over here you have 2 options, either to go for Plus or you can go for Iconic. In Plus subscription, what do you get? You get study material in the form of PDF. But in Iconic, you get study material in the form of booklets. Those booklets will be delivered to your houses. And in Iconic, you get more mentorship sessions. For example, the Plus subscribers, they get like, in 14 days, they get 1 mentorship sessions. These will be getting, Iconic subscribers will be getting 3-4 mentorship sessions in 2 weeks. That is the main difference, right? Now, for example, if you're clicking on Plus, you have to click on 12 months, click on Proceed to Pay. After you click on Proceed to Pay, you'll be redirected to a page, and this is the page which I'm talking about. You just have to put your mobile number on which you'll be getting the OTP, or you can continue with your email ID as well. And eventually, you can get this batch right now at the rate of 5499. And let me tell you, after 2 days, guys, this batch, the Phoenix 3.0, wherein we are training you firstly throughout the year, after 3 days, you are getting the same batch exactly as at 7999, right? Timing of classes. Classes timings, it keeps on changing basically, right? For example, I take class in the morning at 7 a.m. I take class every day, 7 to 9 a.m. Then comes your HSP sir's class. Then comes Yavar sir's class. Then comes Ambika ma'am's class. So at an average, basically, there are 3 live sessions on a given day. But by chance, if you are unable to join the live session, no need to worry. There's a you can watch the session in the recorded format as well, depending on your convenience, right? Fees is 5499. This is a complete fees. It's not monthly. It's not monthly. This is for 1 year complete. Okay. So do get enrolled. Perfect. So with this, I'll be taking a leave, guys. Do get enrolled as soon as possible. And after getting enrolled, you can send me the screenshot on my Telegram, right? WASSIM_BHAT, right? Send me the screenshot of that so that I'll add you in the mentorship Telegram group as soon as possible. Perfect. Perfect, people. Chalo, I'm taking a leave with this. Get enrolled.